Hello, I'm Bridget Goodwin from Australia. I'm going to speak with you today about the use of honeybee venom for various forms of cancer. Some of you may or may not know that chemotherapy, as we know it today, originated from mustard gas, which was a weapon of war first used at the beginning of the 20th century. I did my PhD on top secret experiments on using mustard gas during the Second World War in Australia, using Australian soldiers as experimental subjects. When I published this work, all of the documents in relation to these experiments were secret, and they are still classified today. This is a photograph of soldiers who'd been gassed at Ypres in the First World War in 1915, when mustard gas was first used as a weapon of war. And it created a lot of interest because the autopsies of 75 gassed soldiers were noted by pathologists because their white blood cell count appeared to have dropped dramatically. And quite secretly between the wars, quite a lot of research was conducted into how this chemical behaved in the body. Cornelius Dusty Rhodes was a prominent scientist and active in the chemical warfare service in America between the wars, and he was very interested in this subject of using mustard gas as a potential cancer treatment. And he was involved in using wartime research in secret to develop a future scientific treatment for cancer called chemotherapy. This is the case in 1942 of secret experiments at Yale using mustard gas on a subject known only as JD. JD had cancer and he was exposed to mustard gas, and the scientists observed how the tumours first shrank and then returned. But unfortunately, JD died as a result of this treatment. But the treatment created a lot of interest in the potential of using mustard gas to shrink tumours and possibly be used for cancer. This is the timeline of when mustard gas was first introduced at around 1900 and up until the present day. This is Captain Howard Skipper, Dr. Howard Skipper, who worked in Australia in the secret experiments that I documented. And when he returned to Birmingham, Alabama, Dusty Rhodes and some industrialists were very interested in what he discovered during his time in Australia during this research. And Skipper was given his own lab in Alabama on return because he didn't want to live in New York, and they financed the Southern Research Institute in Birmingham, Alabama, where for many decades Howard Skipper actively worked on mouse experiments using mustard gas and other chemicals to trial different ways of delivering chemotherapy. Skipper told a biographer on the subject of treating childhood leukemia that what he learned in Australia was that the human body and other biological systems can tolerate high doses of certain toxic drugs if the period of exposure is very brief. But if the same dose is given over a long period of time, or even a much lower dose given over a long time, it can be fatal. This is a picture of mustard gas being prepared at Sloan Kettering Memorial Hospital for delivery as a new treatment for cancer, which they didn't disclose at the time was mustard gas, and they called it chemotherapy. This is Dusty Rhodes with the industrialists Reginald Coombe, Alfred Sloan and Charles Kettering, with a plan to develop the new Sloan Kettering Memorial Hospital, which became the original place where chemotherapy was delivered for the treatment of cancer. This is Howard Skipper at the Southern Research Institute, where he worked for many years working on experiments to do with mustard gas and the treatment of cancer. Now, Howard Skipper became known as the architect of what they call the cell kill theory. That is the notion that you need to kill the cells of tumours with as much of the chemical as possible in order to stop the cancer. But the fine line was how to deliver this level of toxicity without killing the patient. While the research in Australia was not publicised, in the United States, similar research was conducted using American soldiers. Unfortunately, unlike Australia, the Americans documented what happened and they compensated people who'd been involved in these experiments. And this report was written about mustard gas experiments during the war, and people were compensated, but this never occurred in Australia. This is Skipper again, with the person he refers to as Boss Kettering, who we understand largely financed his research in the lab in Alabama on mouse experiments based on information he gathered when Australian soldiers were saturated with levels of mustard gas during the war, and triggered a lot of interest in using chemicals to treat cancer. And this is when Howard Skipper actually passed away. His obituary refers to him as the architect of the cell-kill approach to chemotherapy, which was sort of done in secret for many years, but was really only after his death we had a full understanding of just what a huge contribution he'd made to the notion of the cell-kill approach to chemotherapy, which is still in use today. So with chemotherapy, there becomes an issue called drug resistance, and this is still discussed in cancer treatment today. So scientists have wrestled with the idea that when they deliver chemotherapy, ultimately the cells resist the drug and chemotherapy is delivered again and the same thing happens again. So it's become a cyclical treatment of chemotherapy that many have come to criticize as being frustrating and largely ineffective, and has caused many to call for a different way of treating cancer other than the old cell kill approach. What I'm proposing is research that is being conducted increasingly in recent years using bee venom as a kind of chemotherapy drug, except it's a non-toxic natural agent, and unlike the old cell kill approach, does not kill good cells. It has the effect of encouraging apoptosis in cancer without damaging the good tissue. And a lot of research has now been publicised about this. This diagram shows cellular and microbial targets relevant to bee venom components. The method of action of bee venom is through dendritic cells that stimulate the immune system and thereby activate cellular immunity. So bee venom's antioxidant activity is to encourage reactive oxygen species, which simultaneously encourage apoptosis of the cancer cells. It's quite a different process to the cell kill approach of Howard Skipper and quote unquote traditional chemotherapy. A researcher called Faget has acknowledged that the National Cancer Institute advances in molecular biology and genetics of cancer have increased the treatment, but he criticises what they call 3 decades of stagnation in cancer treatment. And he writes that this treatment has been very slow and that there has been a lot of frustration in the fact that traditional chemotherapy using the original mustard gas ingredients has been largely unsuccessful and is calling for new ways to treat cancer. When you mention bee venom to people, you often encourage a notion of terror because many of us have a childhood fear of being stung by bees. So the notion of bee venom sounds quite frightening. However, when you compare it to the cell kill approach of traditional chemotherapy, bee venom is actually a much more bioavailable and much less toxic treatment than traditional chemotherapy. Chinese researchers in 2008 found that in the case of liver cancer, melatonin from bee venom had the potential anti-cancer activity to encourage apoptosis in cancer cells. They showed that melatonin inhibited tumour cell metastases by reducing cell motility and migration via the suppression of the RAC1 dependent pathway. They concluded that melatonin was a potential anti-cancer treatment. In 2020, the Australian researcher Chiara Duffy, in her PhD, was published in the prestigious journal Nature, showed that bee venom killed breast cancer tumours in rats, and this encouraged a great deal of international interest. The Australian researchers acknowledged that apitherapy was an emerging field that could potentially impact the economic aspects of cancer research globally, particularly in under-resourced communities. Since then, there have been numerous studies exploring the use of bee venom, either with chemotherapy drugs or alone. A 2022 review analysed the effect of bee venom and its components on breast cancer cells and reviewed the mechanism underlying the anti-cancer benefits of bee venom. In 2020, researchers into alternative treatments for leukemia reported great success using bee venom. Researchers at the Medical University of Lodz in Poland demonstrated for the first time that melatonin was able to induce the apoptosis process via the intrinsic mitochondrial pathway in different models of leukemia. The researchers noted this was an important potential use of bee venom in the treatment of cancer. Following Duffy, researchers in China in 2021 reported how bee venom is known to strongly stimulate the immune system and is used as a complementary therapy to treat cancer pain in the patients with advanced tumours. The researchers noted that bee venom contained several allergenic protease inhibitors and peptides, and it triggered hypersensitivity reactions, that is, an immune system agonist. The researchers describe how apitherapy, unique to traditional Chinese medicine, features both acupuncture and moxibustion. They compare the burning and swelling caused by bee venom to the medicinal heat from moxibustion. The analgesic pain-relieving effect of acupuncture to reduce pain is enhanced by bee venom, so apitherapy has often been used to relieve pain. The researchers described how in the Hangzhou Red Cross Hospital they used live bee venom to treat a terminally ill cancer patient with remarkable results. They described the case of a 62-year-old male with chemoradiotherapy-resistant advanced liposarcoma. The patient had received multiple surgeries and multiple rounds of chemotherapy, and once this failed, they started using bee venom and found that the patient's condition improved dramatically. Bee venom has been used to treat many different conditions, from acne, alopecia, dermatitis, melanoma, photoaging, psoriasis, vitiligo, and the use of bee venom for cancer is being quite widely used in many countries now by researchers. In 2023, I had the opportunity to go to China for the 4th annual Apitherapy conference, and there we were taken to visit a few apitherapy hospitals, which are very impressive. I'm just going to show you some videos of those now.
他这个颈椎他经常要扎一扎，保健一下。
平时也扎过牛膝。
扎就是，他是常年要保健一下，所以他不怕。
正好有个机会。
正好有个机会，他这2年正好不舒服，给他扎一扎。
正好有地方。让他们照吧。
体验一下就。
不好抓是不是？
就是少。
行了，慢慢抓。
有推拿的手法，其实都是就这些。
这是你看，这是陈氏风疗法的107点。108点、109点、110点，哎，对，啊，这是我们的点，这是它是不在穴位上，它就是它这个就是陈氏。
你的钳子偏短，你不要着急，等它呢还是蛮长的。Really big. For Chinese it's very small. 等一下。
One here, please.
You cannot. It's okay.
Okay.
You open to get.
没有了，那个没有了，好吧。
可以多打几针，风针事业药引那个变换药物也1块。
So the overuse is not necessarily recommended.
Chinese bee.
That is not.
This is a photo of a group of us who were taken to visit a couple of the apitherapy hospitals in China. As you can see, this is one at Fairy Mountain, and there were visitors from many countries practicing in apitherapy who attended this conference. And I believe there's possibly at least 30 hospitals dedicated to apitherapy as it's presented in traditional Chinese medicine for the last possibly 4,000 years. Since apitherapy is becoming better known around the world, many more beekeepers and commercial bee venom producers are selling bee venom, which you can buy from their various websites. I'm just showing you some samples here from Romania, Croatia, and Turkey, where it's possible to purchase medical grade bee venom, which is either delivered as a serum or as powder to be used in topical treatments. So bee venom is becoming quite a famous medicinal product, and the potential to develop this as a commercial industry is also being explored in Australia, and I'm involved in that process as well. Although these countries are very much more advanced than we are in Australia in recognising that bee venom is a potential very powerful bioavailable medicine for many uses. And that's the conclusion of my presentation. I hope you enjoyed it. Please contact me with any questions, and I'll just show you some slides of my references. Thank you.